In ancient mythology, Hermes was the one who crossed boundaries between gods and mortals, between life and death, between the visible and the hidden. He focused on the unity of matter and spirit. He was the mediator and carried messages. In this work, Hermes returns, not with wings or magic, but with geometry. He represents the boson, carrying the messages to build matter. His caducus of serpents is a double helix of spin. It is a bivector that holds the balance of energy between kinetic and static, between reflection and parity, and separates matter from force. The bivector is the origin of our hands and the double helix of life. This is not quantum mysticism. It is real structure made visible, a path between the classical and the quantum worlds. And Hermes, as always, holds the key. The two ways to linearize the Klein-Gordon equation, the material and the abstract, local reality and non-local indeterminism, and fundamentally the concept of dualism and complementarity. That key leads us to two visions, and only one can be correct. Is nature fundamentally a fermion or a boson? You already know the classical quantum correspondence principle for energy time, position momentum, angular momentum and angle. This is a consequence of the wave-particle duality of quantum mechanics. The two complementary components are exclusive and dual. They are described in complementary Fourier spaces. And what about spin? Here I will show the classical origin of spin. We do not have to postulate spin. In quantum mechanics, spin is a point particle of intrinsic angular momentum. But we will not do quantum mechanics here, only classical mechanics. We will find a classical spin and the quantum correspondence. We get a spin up and down in a Stern-Gerlach experiment. That means one spin spins left and the other spins right. They have the property of handedness, which is called chirality after the Greek for hand. So that seems to say that spin is a two-state system and has a left and a right hand. Mathematically in quantum mechanics, spin is represented by a two-dimensional vector in a Hilbert space. They are fermions of spin 1/2. Spin has SU2 symmetry and allows superposition. This leads to entanglement, wave function collapse, and the Born rule. From this, the standard model of particles follows, treating fermions as the most fundamental particles in nature. This is only true, I will explain, in a magnetic field. Then we measure fermions. Also, this is spin at low energy, and to find the origin of spin, we must look at the work of the famous physicist Paul Dirac. He derived his equation by linearizing the Klein-Gordon equation, but there was a problem. The Klein-Gordon equation describes one particle, and the Dirac equation describes two. After a lot of thought, he came up with his matter-antimatter pair. I will not discuss his famous gamma matrices, except to say that they must anti-commute to make sense. I have depicted his pair as two separate spins. They are reflections of each other. See the bisecting mirror plane. They are equal in every way except opposite, which motivated his matter-antimatter idea. Of course, when the positron collides with an electron, it is annihilated. So really, Dirac throws away half the Dirac solution. We are left with only fermions, which spin either left or right. Dirac did not know there is a second way to linearize the Klein-Gordon equation. It appears no physicists know either. This is all I did. I multiplied one of the gamma matrices by the imaginary number I. Then we get a bivector, because I sigma 2 is equal to sigma 3 sigma 1, and is a bivector of Pauli matrices. Dirac's solution is in the laboratory fixed frame, which is Minkowski space, but the bivector has its own body fixed frame. So I figured, let's have a look at a classical bivector. It is two vectors joined by a cross product. The cross product is a bivector.
It is an oriented plane, and it has the chirality of a left hand, A cross B, and a right hand, B cross A, which is equal to minus A cross B. The plane is oriented by the normal to the surface n. I will use a different notation, and that is the wedge product, which is A wedge B. The wedge is good for any dimension, not just for the special case of the cross product in 3D space. I define a classical spin as the wedge product of two axes, S1 and S3. These are the angular momentum vectors that form the bivector. So this is a big change. A bivector spin is not a point particle. It is a structured item in three-dimensional space. There is no mathematical difference between the basis for either linearization. Both do the job equally well. Which one is correct? The two ways give different choices. I argue it is the bivector, and for the last 100 years physics has been barking up the wrong tree, and therein lies the problem with the Standard Model.
The second linearization of the Klein-Gordon equation is a black swan event in physics, rare, unexpected, and paradigm shifting. It cannot be ignored, for if accepted, it will fundamentally reshape our understanding of nature.
You must decide. It is your responsibility as a scientist to look at both cases and decide which is correct. Here are the choices. The Standard Model has fundamental particles which are fermions, that is, chiral vectors with two states. In contrast, the bivector Standard Model is not a two-state vector in an abstract Hilbert space, but a real structure in our three-dimensional space, where the two axes add up to give a spin-1 boson. The axes align, and that is spin up and spin down. Fermions are not fundamental particles, but the blades of a spin-1 boson. That is one of the changes we find.